Hi guys, this is Dr. P and today we'll discuss the second part of the lesson ellipse. Parts of an ellipse. So the two fixed points that are given, F1 and F2, are called foci. The distance between foci equals with 2c, it's called focal distance. It's the blue distance. Then do we have also the major axis? The endpoints A1 and A2 are called vertices of the ellipse. And the minor axis, the vertical line B1 and B2 are called also co-vertices of the ellipse. These numbers A, B, C are very important and we will emphasize the relationship. So C squared equals A squared minus B squared, and this will be very helpful to find the focal distance where the A and B are given. Let's look a bit at the coordinates of this ellipse. We consider at first the ellipse that has the center 0, 0. So that means that this is the x-axis, the vertical line is the y-axis, and here is the origin of the system of coordinates. That's why the first vertex A1 has the coordinate A and 0 because you have here exactly half of the major axis. And the other vertex of the ellipse is negative A and 0 because you are going in the negative part. In the same way, you can explain the coordinates of the co-vertices B and respective negative. The equation, if you look at the equation of the ellipse, what states this equation? That you have a point P of two coordinates x and y that is on the ellipse. Then if you plug in x and y, both coordinates in the equation, this should be a true statement all the time. But if you look carefully, you understand that this makes sense. Why? Because x and y both are measured horizontally on x-axis. And that's why the second part, y and b, makes the same sense because y and b are measured vertically. Let's go now to the next step and let's consider the ellipse that it's centered in an ordinary point h and k. So instead of 0, 0, we have the center h and k. And that's why this is a translation from this point to this point. So you just translate the ellipse from the center origin to an ordinary center. How you find the coordinates of all the vertices and co-vertices? You just add h and you just add k to both coordinates. You can check this relationship for both coordinates. Then, how the equation is transformed. If you look that x is translated, it makes sense to consider the fraction x minus h over a. And although it makes sense because you have the center h and here you just flip the sign and you have minus h. So this is like the circle equation because it's the same principle. And if you think there is a logic behind, because ellipse can be considered a circle when the semi-axis A and semi-axis B becomes equal and they becomes radius. And the last form of the ellipse is when we have the ellipse with major axis vertical. The center is the same, h and k, but the major axis from horizontal, it becomes vertical. So that's why if you look a bit at the equation, it makes sense because a from horizontal should be translated to the vertical coordinates on the second fraction. And although b that was vertical becomes now horizontal, so that's why b appears to the first fraction. In the